This is the Chapter 12 Customary Measurements Review Test for Go Math 4th grade. Number 1, Mrs. Miller wants to estimate the width of the steps in front of her house. Select the best benchmark for her use. Remember, benchmark is the measurements that we use to give us an idea of how big these things are. So to measure the width of the steps in front of her house. So you're thinking at least, if this is the doorway to our house, the steps are going to be at least as big as the doorway. So we want to measure that width. So if we do that, measuring with my fingertip, that would take me forever. That would not be a realistic measurement. The thickness of a dime, again, that's not going to be a realistic measurement to have measured basically the width of a doorway. So now we're down to the width of a license plate, which we talked about. A width of a license plate is about the width of our paper. Okay. Or how far she can walk in 20 minutes. Well, I know it's not going to take me 20 minutes to walk from this side of the step to this side of the step. So that means the only reasonable benchmark to measure the steps in front of our house is the width of a license plate. All right, Franco played computer chess for 3 hours. Leanne played computer chess for 150 minutes. Compare the time spent playing computer chess. Complete the sentence. So really, we are comparing 3 hours compared to 150 minutes. And when we are comparing two different measurements, we want to make them so they are both the same. And it is easier to turn hours into minutes. So we're going to multiply our 3 hours by 60 minutes because there are 60 minutes in 1 hour. 6 times 3 is 18. Add my 0. So that means 3 hours is 180 minutes, which means 180 minutes is greater than 150 minutes. So to complete the sentence, we know Franco played longer, so Franco played for blank longer than Leanne. So now we need to figure out how much longer. Well, we do 180 minutes, subtract 150 minutes, and that means that he practiced for 30 minutes longer than Leanne. Okay, select the measurements that are equal. Mark all that apply. So essentially on this, we are trying to find the feet, the inches, and the yards that all equal the same amount. So I am going to take my yards, which is my biggest, and I'm going to multiply it by 3. That was going to tell me that there are 45 feet in a yard. And since that's the only yards there is, I know that that's going to be one of my options. So 15 yards and 45 feet are the same thing. Now I can take my 45 feet and I can multiply it by 12 because there are 12 inches in 1 foot. 5 times 2 is 10. 4 times 2 is 8 plus 1 is 9. And then I'm going to draw my collar, lay an egg. 1 times 5 is 5. 1 times 4 is 4. And when I add those together, I get 540. So 540 inches is the same thing as 45 feet and 15 yards. All right, Jackie made 6 quarts of lemonade. Jackie says she made 3 pints of lemonade. Explain Jackie's error. Well, we know that 1 quart equals 2 pints. And so when Jackie said that 6 quarts was 3 pints, she actually divided by 2. So we could say that Jackie divided the quarts by 2 instead of multiplying. Remember that if we're going from a big unit to a small unit, we multiply. So 6 times 2 equals 12 pints in 6 quarts. All right, question 5. We are making a tally chart. Now, here is the title for our line plot. So we're going to copy that down onto the title line. And we want to make sure we have the label so we know what our measurements represent. So now I've got my title. Now I'm going to look at my data and I can see I have 1/4, 3/4, 1/2, and 1/4. So I'm going to put those in. So in smallest to biggest, I have 1/4, 1/2, 3/4, and 1/2. And then I'm going to look at this data and I'm going to check it off as I put the tallies on. That way I know I have marked each one, because sometimes if we don't keep track, it's very easy to forget some or to use some twice. All right, so now that I've got all of my tallies, the tally marks tell me how many X's to do. And on my labels for my graph, I'm going to use these same labels. So I'm going to have 1/4, 1/2, 3/4, and 1. On 1/4, there are 2 tallies, so that means 2 X's. On 1/2, there's 1 tally. 3/4 has 3 tallies, and 1/2 has 4. And just to double check myself, I'm going to have 4, 5, 6, 7, 8, 9, 10 X's, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So that way I'm double checking myself to make sure that I have not forgotten anything. Now part B says to explain how we use the tally table to label the numbers and plot the X's. I can say that the number of tallies will tell me how many X's to draw on the line plot. And part C says, what is the difference between the longest time and the shortest time? Well, my longest time, it's not talking about how many pieces, it's talking about the distance. So the longest time is 1. The shortest time is 1/4. So 1 minus 1/4 equals 3/4 of an hour. Because remember, 1/2 is the same thing as 4/4 minus 1/4 equals 3/4. All right, next question, number 7. Write the symbol that compares the weights correctly. So we have 128 ounces, we have 8 pounds. Well, I know that there are 16 pounds in 1 ounce, or 16 ounces in 1 pound. So I'm going to multiply 8 pounds times 16. 6 times 8 is 48. 8 times 1 is 4, or 8 plus 4 is 12. So that means that 128 ounces is equal to 8 pounds. 8,000 pounds compared to 3 tons. Well, I know that 1 ton has 2,000 pounds, so I'm going to multiply that by 2,000 times 3, and that gives me 6,000 pounds. So 8,000 pounds is greater than 3 tons. All right, number 8, Dwayne bought 5 yards of wrapping paper. How many inches of wrapping paper did he buy? Well, in 1 yard, there are 36 inches. So we're going to do 36 times 5. 5 times 6 is 30. 5 times 3 is 15, plus 3 is 18. That means there are 180 inches in 5 yards of wrapping paper. All right, a sack of potatoes weighs 14 pounds 9 ounces. After Wendy makes potato salad for a picnic, the sack weighs 9 pounds 14 ounces. What is the weight of the potatoes Wendy used for the potato salad? Write the numbers to show the correct subtraction. So now when we are subtracting, remember, we have to borrow the right number of pieces. So if I only have 9 ounces, I cannot subtract 14 ounces. So I need to get more ounces. So I'm going to turn 14 pounds into 13 pounds. I'm going to borrow 1 pound. And I know that when I borrow 1 pound, I am borrowing 16 ounces. So 9 plus 16 is 25 ounces. 25 ounces minus 14 ounces is 11 ounces. And 13 minus 9 is 4. So my correct answer is 4 pounds, 11 ounces. Sabita made this table to relate 2 customary units of liquid volume. List the number pairs for the table. So the number pairs are this with this. So my number pairs are in parentheses 1, 2, 2, 4, and I like to put semicolons in between so it separates them better. 3, 6, 4, 8, and 5, 10. And I can tell that this one times 2 equals the second number in the chart. So I need to figure out what has 2 smaller measurements inside it. So I know that my options are 1 pint equals 2 cups. I know that 1 quart equals 2 pints. So I'm going to choose from those, and you could do either one. So I can say these are the pints. 1 pint is equal to 2 cups. I could also put quarts on the first one and say that 1 quart is equal to 2 pints. So either answer would work for the label. Now let's go back and make sure we've answered all the questions. So list the number pairs for the table, then describe the relationship between the numbers in each pair. So you could say the second number is 2 times the first number. That's the relationship. And then label the columns. We've labeled it, so we could then say there are 2 pints in 1 quart, or you could say there are 2 cups in 1 pint. And it just depends on which labels you chose to use. All right, moving on. Question 11 is another line plot. The table shows the distances some students swam in miles. Complete the line plot to show the data. So we have, looks like we have 1, 2, 3, 4, 5 eighths. And so our labels will be 1/8, 2/8, 3/8, 4/8, and 5/8. Now I would highly suggest doing your line plot off to, or your tally chart off to the side to help you keep track. This is definitely optional. It's not required, but I feel like it really would help. So we have 1/8. I'm just going to check them off again as I get them done so I know that I am using them all. So now you can see I have went through my entire data and made a tally chart for that. And so I can put 2 x's on 1/8, 2 x's on 2/8, 4 x's on 3/8, 3 x's on 4/8, and 1 x on 5/8. What is the distance between the longest distance and the shortest distance? Well, these are the distances. So our longest is 5/8. Subtract 1/8 is my shortest, would give me 4/8. So 4/8 of a mile is the distance. An elephant living in the wild park weighs 4 tons. How many pounds does the elephant weigh? Well, I know that 1 ton is 2,000 pounds. So I'm going to do 2,000 times 4. 4 times 2 is 8. Add my 3 zeros back in, and that gives us 8,000 pounds. All right, next question, number 15. Cheryl is making a mixed fruit drink for a party. She mixes 7 pints each of apple juice and cranberry juice. So that means 7 pints for apple juice and means plus 7 pints for cranberry juice. So when I get that, I get 14 ounces, or 14 pints, I'm sorry. 14 pints. The question wants us to give our answer in ounces. So we are going to do 14 times 16 because there are 16 ounces in 1 pint. So 14 times 16, 6 times 4 is 24, 1 times 6 is 6, plus 2 is 8, and I should have drawn my turtle head so that I could draw my collar, lay an egg. 1 times 4 is 4, 1 times 1 is 1, and when I add those together, I get 224 fluid ounces. Hamid's soccer game will start at 11 a.m., but the players must arrive at the field 3/4 of an hour early. We know that 1/4 of an hour is 15 minutes. So 3/4 would be 45 minutes. The game must end by 1:15 p.m. Hamid says he needs to be at the field at 9:45. Is he correct? So I'm going to go ahead and turn my paper so I have a little bit more room, and I'm going to draw a line, like a timeline. I know that the game has to end at 1:15. And I also know that they need to arrive 3/4 of an hour early. And the game starts at 11 o'clock. So if the game starts at 11 o'clock, here's my starting time of 11 a.m. And I need to go back 3/4 of an hour, which means I need to go back 45 minutes. So if I go back 45 minutes, I'm going to actually jump 30 minutes first. So 30 minutes would put me at 10:30 a.m. And if I go back another 15 minutes, because 15 plus 30 is 45, that means I need to arrive at 10:15 a.m. So Hamid says he needs to arrive at 9:45. Is he correct? No, he needs to arrive at 10:15 a.m. And it's always important to have a.m. and p.m. because we need to know like what time of day that means. Now the park closes at 6:30. There is a 15-minute game break between each game played at the park, and each game takes the same amount of time as Hamid's soccer game. How many more games can be played before the park closes? So we first have to figure out how long his game was. So I'm going to go back to my original timeline. From 11 a.m., if I jump 1 hour, that puts me at 12 o'clock p.m. And I can jump 1 extra hour, and that would put me at 1 o'clock p.m. And then I have 15 minutes to get me to 1:15 p.m. So that means that my game each game is 2 hours and 15 minutes long. So I'm going to make a new timeline here that each game is 1 hour, 15 minutes. So I'm going to make a little note for myself. One game equals 2 hours and 15 minutes. The park closes at 6:30, and we want to know how many more games. So from 1:15 to 6:30, we want to know how many games we can fit in. So I'm going to start my timeline at 1:15 p.m. That's end of game 1. Now it says there are 15-minute breaks between each game. So I need to add 15 minutes here for a break. And that puts me at 1:30 p.m. Now game 2 goes for 1 hour, 2 hours, and 15 minutes. So there's 1 hour, 1 hour, and 15 minutes. 1 hour would put me at 2:30. Second hour would put me at 3:30. Add my 15 minutes, puts me at 3:45 p.m. And this is game 2. So then I'm going to add a 15-minute break. That's the break. And that puts me at 4 o'clock p.m. So from 4 o'clock p.m. starting the game, 1 hour puts me at 5 p.m. Another hour puts me at 6 p.m. And 15 minutes puts me at 6:15 p.m. That means I really can only do 2 more games after Hamid's game, because there's game 2 and game 3. Hamid's game was game 2 or game 1. So how many more games can be played? They can play 2 more games. All right, moving on to the last page. So question 18, draw lines to match equivalent time intervals. Well, we have to figure out a half an hour is, we know that that would be 30 minutes because half of 60 minutes is 30, but there is not 30 minutes here. So I know I'm going to have to turn it into seconds. So I'm going to do 30 minutes times 60 seconds each minute gives me, 6 times 3 is 18, 2 zeros behind it, 1,800 seconds. So 1/2 hour is 1,800 seconds. Now, I know that in every hour, to get to minutes, there are 60 minutes in an hour. So I'm going to multiply this by 60, which would give me 120 minutes. I'm going to look to see if that's an option, and that is not an option. So once I do that, then I'm going to figure out how many seconds that is. So I would take 160, I'm going to multiply that by 60 because there are 60 seconds per minute. 6 times 12 is 72, add my 2 zeros, which gives us 7,200 seconds. And we look, and that one is an option. So I always like to start by going down one size in measurement and then going down again if I need to. Okay, so 3 hours, if I multiply that by 60 minutes, that gives me 180 minutes. And that is an option, so that one is done. 8 hours. Well, I know I can't turn 8 hours into 3 days. So it's very likely that it's 480 minutes, but we're going to do the math to double check. 6 times 8 is 48. Add my 0, and that is correct. Now, it only leaves one option, but we still want to double check because you don't ever want to just guess. You don't want to assume that it's always the right answer. So 72 hours. I know that there are 24 hours in one day. And I'm trying to see if it's 3 days. Now, I could do 72 divided by 24, but that's kind of a hard problem. And I don't know about you, I don't know my 24s very well. So my other option is to turn my 3 days into hours by multiplying it by 24. 3 times 4 is 12. 3 times 2 is 6, plus 1 is 7. So there are 72 hours in 3 days. And so we've done the math, and it does match up. All right, Anya arrived at the library on Saturday morning at 11:10 a.m. She left the library 1 hour and 20 minutes later. Draw a timeline to show the end time. So I'm going to look at these tick marks and see how many minutes these are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are 5-minute intervals. So 11:05, 11:10. So we're going to say at 11:10 a.m., that is when she arrived. So I'm going to say that's the arrival. She left the library 1 hour and 20 minutes later. So 1 hour would put her, so 1 hour puts her at 12:10 p.m. because once we pass noon, we're in p.m. now. And we went another 20 minutes. So if I go 20 minutes, that's 5, 10, 15, 20 minutes, which would put me at 12:30 p.m. So she left at 12:30 p.m. The table shows patterns for units of measurement. Write the correct labels in each table. So what this table is saying is one of these bigger measurements is made by 3 smaller measurements. So there are 3 blanks in a blank. Well, I know there are 3 feet in 1 yard. There are 7 blanks in 1 blank. Well, we know there are 7 days in 1 week. And 4 blanks in 1 blank. Well, there are 4 cups in 1 quart. Frankie is practicing a 5-kilometer race. His normal time is 31 minutes, 21 seconds. 31 minutes, 21 seconds is his first time. Yesterday, it took him 29 minutes and 38 seconds. How much faster was yesterday's time than his normal time? So we can't take 38 seconds away from 21. And the reason I am subtracting is because it says how much faster. We're finding the difference. So I can't take 38 from 21, so I'm going to borrow 1 minute, and I'm going to add 60 seconds. That means all together now I have 81 seconds minus 38 seconds. So when I subtract that, so 11 minus 8 is 3, 7 minus 3 is 4, so 43 seconds. 30 minus 29 is 1 minute. 1 minute, 43 seconds. All right, the best thing you can do to help you prepare for this test is to practice those measurements. You really need to make sure that you are confident in converting our customary measurements of weight, capacity, volume, and length. Good luck on your test.